they ordered it for me. All right. Powers of monomials. Anything that is being raised to a power, that's that little exponent that you see up and above. There are two scenarios that we're going to talk about today, and they're both in gray on page 155. Okay? The first one we're going to talk about is the rule of exponents for the power of a power. So if you have something, and this is the way I'm going to just write it, that has a power attached to it, and then you raise that thing to another power. Well, here, you know what? I'll change the number to second. This is the power of a power. Okay, so it's a to the third to the second. All right, the power of a power. When you have something like this, it literally means take the item in parentheses, which is a to the third, and multiply it by itself this many times.
So the reason that you did is a times a times a times a times a times a.
Otherwise known as a to the sixth in this case. Exactly right. This is, by definition, power of a power. And they show it in their book as well, but I just feel like it makes more sense to show it this way. I'm going to use their example 1 to make it really clear, and I have a couple examples that'll help you guys.
What page?
We are 155. So x to the fifth being raised to the third power. As Percy already said, it's quintuple, quintuple. So x to the fifth done 3 times. I did it too many times. X to the fifth 3 times. So that's like saying x to the fifth, x to the fifth, x to the fifth. X to the 15th is exactly right. So when it's like that, Percy says, so when there is a power in parentheses and an exponent outside, you simply multiply the exponents. Okay?
Oh!
Okay? When you have an exponent in the parentheses with another one outside, you simply multiply the exponents. That is the rule for power of a power. Okay, I want to do a couple more examples just so that you guys feel comfortable. I've got, this is not in your book, m to the third 4 times. Now I can write it out. Once, twice, 3 times, 4 times, and then you would say, well then it's 3, 6, 9, 12, and you'd be right. But using the rule, you could simply multiply 3 times 4 and you would come up with the 12. Okay? Just one more. X squared 5 times. 4, 5. And obviously you don't have to do this. I'm just doing it so you can see it. X squared 5 times is going to be 2, 4, 6, 8, 10. Okay? X to the 10th. This is power of a power. Okay? They give you 2 more examples of those. In example 2, they have u to the 4th 5 times. You guys see that one? So it's obviously u20. But I do want to do example 3 with you. Example 3, because that one requires you to take a couple of steps. Otherwise, you could make an error. So, negative a squared to the 3rd power. Now don't let that all scare you that there's just too much chaos going on. I'm going to break this down. Let's pretend like there's nothing here, like that 3 doesn't exist. And all you have to do is negative a squared. That literally means negative a times negative a, right? So you have positive a squared as your result. So that would lead me to believing that I could write positive a squared, and then there's my 3. Now you can go back to the original rule, what I just shared with you guys, whereas when it's a power of a power, and it's separated by a parentheses or a bracket, you multiply the exponents. Okay? But be careful, if the negative is inside, it stays with that and gets squared. If the negative were outside, it would be the opposite of. So it would just still have stayed negative. Okay? That's the trickiest thing for me anyway. All right. Example 4. Now these have all been with 1 as a coefficient. 1x squared, or x to the 5th. 1a cubed. -1. Okay, all of these were with 1. But if you look at example 4, we now have a coefficient that is something other than 1. A 2, for example. Okay? So this here is 2x to the 1st. I can think of that as the 1st. And that is being cubed. When you have a coefficient, the power on the outside, the exponent, affects both pieces. So you're going to cube the 2, which is 2 times 2 times 2, gives you 8. And you're going to, of course, follow the rule for the power of a power. X to the 1st times x to the 3rd is x third. Okay? And I only drew that 1 there just to kind of remind us that it's still got a power even though there's no exponent there. Okay? So that's how that gets changed. Let's do one more, just like that one. And you could write it the way they do it. Did you notice how they did 2x times 2x times 2x? And then they grouped and associated so that you came up with 2, 2, 2 and xxx. Or you can do it the way I do. 2 cubed is 8, x cubed is x cubed. Here's one more just to make sure. Okay. So we're going to 2 to the 4th. We're going to raise 2 to the 4th power. So 2 times 2 is 4, times 2 is 8, times 2 is 16. See, that's how I do it. And y to the 1st to the 4th is y to the 4th. Okay? Now, we've just talked about power of a power. The next thing we're going to learn about, and it's related, it's quite similar, but it's a little bit different, is power of a product. Okay, power of a product. That means if there is it's really similar to this. If you have, let's see, x, y being raised to the power of 4, okay? That means that each of these pieces gets raised to the 4th power. Okay, stay with me. X gets raised to the 4th power, which is x to the 4th, and y gets raised to the 4th power, which is y to the 4th. So this is a multiplication thing, x times y. I know you don't think of it that way, but literally when you've got 2 variables side by side, they're being multiplied. And this is the exponent that raises it to the 4th power. Okay? Therefore, they call this power of a product. Best thing I can say to you is make sure everything that is in parentheses receives the power. Okay? Receives that power. We're going to go ahead and move on to page 156, and we're going to do example 5, which really is quite similar to this. Okay? It's not a whole lot different. Example 5. So example 5 says -2k to the 5th power. K Okay, that means you have to take that -2 and raise it to the 5th power. Do you guys remember when we talked about negatives and positives receiving powers, that if it's a negative number being raised to an odd power, the result is still negative? Hopefully you remember that, but if not, that's a quick reminder for you. So the result of -2 to the 5th power is -32. And the result of k to the 5th power is k to the 5th. So what I literally did is I broke up this product and made it -2 to the 5th times k to the 5th. Okay, that's literally what I did to get me to the answer. And they've got that written in the book too. I just don't usually write this out. Okay? You guys okay so far? All right.
Wait, so
Go ahead.
could we just put -32
That's your answer.
Oh, I thought you meant like -2 times 5 times.
No, because literally what you're doing when you solve this is you are taking -2 and raising it to the 5th power. And that's what I have here.
Okay, I thought.
Yep, and you've got your k and you're raising it to the 5th power, and that's what's happening there. Yeah, I'm sorry about that. Okay. I've got another one like that I want to do. We're going to do -4 mn3. Okay, so if we do it this way, we're going to raise our -4 to the 3rd power, right? That's the -4 raised to the 3rd power. We're also going to raise our m to the 3rd power and our n to the 3rd power. The result of that is 16 times 4, which is what, 64? Yes. And since it's being raised to an odd power, it stays odd. -64. MMM is m cubed. NNN is n cubed. Okay? So I went from this, and then each thing in here got raised to the 3rd power. Therefore, the answer is right there. Okay? Takes practice. That was example 5. Now, example 6, we're going to do example 6 and 7 and then a few more samples. But example 6 says evaluate if you're given a value for t, and they say t equals 2, then what does each of these items mean? Like A, which is 3t cubed. Notice there's no parentheses, there's no brackets. The only thing that is getting cubed is the t. This is really important. The only thing that is getting cubed is the t. So you can literally rewrite this by saying 3 times 2 cubed. Okay? Because it's the t that's getting cubed, not the 3. Alright, it's not in parentheses, so the 3 is not getting cubed. So that becomes 3 times 8, right? And then your end result is 24. It's very important that you kind of write these steps, because if you try to do it all in your head, it's easy to get lost. That was A. B, slightly different scenario. 3t in parentheses being cubed. Do you guys see the difference? Now I am saying the product of 3 and t is being cubed. Well, 3 times 2 is being cubed, right? So that's 6 is being cubed. And the result of 6 cubed is 216. And finally C, they changed it up a 3rd time. What if they say 3 cubed t cubed? Well, each of these is being cubed separately. So the result of 3 cubed is 27, right? And t cubed was what? 2 cubed, 2 times 2 is 4 times 2 is 8. So it's 27 times 8, which also is 216. Now look at this, and this is the same as this. 3 cubed t cubed, but it's written differently, okay? So I would still follow the steps as they're laid out. Example 7. We've got powers of powers and powers of products going on. So we're going to do this. This is the hardest type right here. If you're given stuff in parentheses, this is a product. This literally means negative 3 times x times y, 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 y. All of this is getting raised to the third power. Okay? So that means the coefficient of 3 is getting raised to the third power. And that means that the x squared is getting raised to the third power. And that means the y5 is getting raised to the third power. Okay? You don't have to write it that way if you don't like it. That works the best for me. Remember, any negative being raised to an odd stays odd. So 3 times 3 is 9 times 3 is 27. So it's negative 27. When you have power of a power, you simply multiply the exponents. And remember, there's no coefficients, coefficient of 1. So you don't have to worry about the number preceding the letter because that was this right here. So x squared cubed is x6. y5 cubed is y15. All right? I would like to do one more like that one. This one's not in your book. 4a cubed b squared raised to the 4th power. Who's got a calculator? What's 4 to the 4th? Yeah, what's 4 to the 4th?
256.
Yep, 256. Okay, so that's the coefficient 4 raised to the 4th power. So that's 256. A third raised to the 4th power is going to be A12. Okay, last bit. B squared raised to the 4th power, and that's B8. Okay, so I took the coefficient, raised it to the 4th power, which gave us 256. I took a cubed, raised it to the 4th power, indicated right here. That got us A12. And I took b squared, raised it to the 4th power, and that's B8. Okay? How are you guys feeling about this so far?
Good.
Okay. All right. I'll let you guys get started.